Right now, while you're watching this, your PC could be sending data to some server you'll never lay eyes on. Maybe it isn't happening this exact second, but it's not some far-off someday thing either. It's happening now. Every app you launch, every button you tap, every time your computer freezes at the worst possible moment, a small chunk of data slips out of your machine and heads straight for Microsoft. They label it diagnostic data. Most folks have a different word for it, spying. And here's the twist almost nobody's talking about. While everyone's been online debating whether Windows keeps tabs on you, something far bigger has been quietly taking shape behind the scenes. A shift so enormous it could render every password, every encrypted file, and every private message you've ever sent completely exposed within a few short years. And the operating system leading the charge against that outcome isn't Windows, it's Linux. Stay with me, because by the time this video wraps up, you'll understand exactly what your PC knows about you, why the quantum computing age is nearer than you'd guess, and why that free, open-source system tech geeks have relied on for decades might be the only real barrier between your data and total exposure. Let's tackle the obvious issue first, Windows telemetry. If you've ever popped open Task Manager and spotted a background process silently pushing data across your network, you know that uneasy feeling, like something's watching. That's not paranoia talking. Microsoft flat out admits it gathers information from every Windows PC out there. Device specs, driver versions, update status, crash logs, hardware IDs. This has been going on since Windows 10 debuted in 2015, and it triggered backlash almost instantly. Critics likened it to something ripped from a dystopian novel, a telescreen silently reporting your every move back to corporate HQ in Redmond. Dramatic, sure, but the concern was legitimate, and it pushed regulators to step in. Back in 2017, the Dutch Data Protection Authority looked into Windows 10 and concluded that Microsoft's telemetry settings failed to properly secure informed user consent. In plain terms, people genuinely didn't know what data was being gathered or why. A year before that, French regulators issued an official warning over excessive data harvesting linked to Windows advertising IDs. These weren't fringe blogs stirring up noise. These were government watchdogs, backed by law, holding a trillion-dollar company accountable. Microsoft responded by tightening its controls and rolling out more transparency features, but the trust damage was already done. Once people believe their OS is spying on them, that belief is nearly impossible to erase. So Microsoft tried a different tactic, transparency. In 2018, they launched a tool called the Diagnostic Data Viewer. The concept was straightforward. Let users watch the telemetry events leaving their own PC as they happen. Sounds great in theory. In practice, what you get is a dense wall of technical logs that would make even seasoned IT pros squint. Timestamps, event labels, cryptic field values. It's transparency in the strictest technical sense, but it's not something your grandma is going to sit down and comb through on a lazy Sunday. Still, credit where it's due, the tool exists, and anyone determined enough can dig through it. Microsoft has even quietly acknowledged that it samples optional data from only a slice of devices, meaning not every telemetry event comes from every machine. Enterprise and education customers get noticeably more control, including admin templates and API access that let large organizations audit exactly what's leaving their systems and why. That level of oversight simply isn't available to the average home user. Home and Pro editions just get a basic toggle between limited and what used to be labeled full diagnostic data, with no officially supported way to shut the mandatory stream off entirely. Third-party tools like Shut-Up10 or W10 Privacy exist to strip telemetry down even further, but Microsoft doesn't officially back tinkering with the system in that way, and messing with unsupported tools always carries a bit of risk. There's also a newer wrinkle worth mentioning. In recent Windows 11 Insider builds, Microsoft rolled out a more targeted telemetry system built specifically to catch performance slowdowns. The concept is that when your system detects lag, stuttering, or slowdowns, it logs system data locally on your own device first. Nothing gets transmitted anywhere until you personally choose to send that log through the feedback hub. On the surface, that sounds like a sensible, consent-driven approach, but critics were quick to flag a real issue. The phrase sluggish performance is vague. Nobody outside Microsoft knows the exact threshold that triggers a log. Is it a frame rate dip, a memory leak, a frozen process? Without clearly published criteria, users and IT admins are left wondering just how closely their systems are being watched, even with good intentions behind the design. Now here's where things get genuinely interesting, and where a lot of the panic starts to fall apart. Tech journalist Ed Bott spent more than 10 years digging into Windows telemetry claims. Not scrolling Reddit threads or viral tweets, actual network monitoring, actual documentation, actual conversations with senior Microsoft executives. His verdict after a decade of research? There's no proof Microsoft is secretly scooping up your emails, documents, photos, or private chats through telemetry. The required diagnostic stream deals with mundane stuff: device attributes, Windows and driver versions, crash signatures. It's not built to capture what's inside your files. Microsoft has clearly stated it doesn't use crash data, browsing history, speech, typing, or handwriting input for advertising. But here's the honest, nuanced reality, and it matters. On consumer versions of Windows, that mandatory telemetry stream can't be completely switched off through any supported method. You can dial it down, you can't turn it off entirely. There's also a separate setting called Tailored Experiences, which draws on a portion of optional data to personalize suggestions and ads. And while you can disable that particular feature, the fact that it's on by default still rubs a lot of people the wrong way. This is the trade-off sitting at the core of modern computing. Microsoft claims telemetry helps them squash bugs quicker, patch security holes before they spread, and keep more than 1 billion monthly active Windows 11 devices running smoothly across a near-endless mix of hardware. That's a genuinely tough engineering challenge, and telemetry does help address it. But convenience always has a price, and here that price is a slice of your control over your own machine. Take a second to think about that scale. Microsoft has reported more than 1 billion monthly active Windows 11 devices worldwide. That's a near limitless combination of hardware, drivers, and third-party software. There's simply no realistic way for Microsoft's engineers to manually test even a small fraction of those setups. In that specific sense, telemetry works less like a hidden camera and more like a massive automated feedback loop, helping a company that size keep things running for over 1 billion machines. Whether you're okay with that trade-off is a completely different question from whether it's technically necessary at that scale. This isn't a black and white issue, no matter how loudly either side shouts online. Windows telemetry isn't some covert operation stealing your identity while you sleep. But it's also not something you get a completely clear-cut choice about, especially on Home and Pro editions. And that lack of full user control is precisely why more privacy-minded users have started looking elsewhere, not out of pure conspiracy thinking, but out of a genuine desire to actually own their computer again. And that leads us into the part of the story most people are completely overlooking. Because while everyone online is busy arguing over telemetry settings buried 3 menus deep in Windows, a truly world-altering problem has been quietly closing in: quantum computing. Right now, the encryption safeguarding your bank account, medical records, private messages, and basically the entire global financial system depends on math problems that are nearly impossible for ordinary computers to crack, factoring massive numbers, working out elliptic curves. Problems like these would take a classical supercomputer thousands of years to solve. That's been the foundation of digital security for decades. Quantum computers flip that equation entirely. Using something called Shor's algorithm, a sufficiently powerful quantum computer could theoretically break RSA and elliptic curve encryption, not in thousands of years, but in hours or days. Read that again: hours or days. This isn't science fiction anymore. Governments, universities, and huge tech companies are racing right now to build these machines. And while a fully functional, cryptographically dangerous quantum computer doesn't exist just yet, most serious researchers agree it's a matter of when, not if. Here's the part that should genuinely unsettle you. Attackers don't need a working quantum computer today to damage you tomorrow. There's a tactic security researchers call harvest now, decrypt later. It works exactly as it sounds. Bad actors intercept and quietly stash away your encrypted data today, even though they can't crack it yet. They simply wait. The instant quantum computers become powerful enough, they go back and unlock everything they've been stockpiling for years. Your old emails, financial records, private conversations, anything encrypted using today's standard methods could end up readable after the fact. This isn't some future concern. It's unfolding right now, quietly, while most of the internet keeps chugging along exactly as it always has. Because of that exact threat, the entire tech world has been racing towards something called post-quantum cryptography, or PQC. These are brand new encryption algorithms specifically engineered to withstand attacks from quantum computers, not just conventional ones. In August 2024, the National Institute of Standards and Technology, NIST, finalized the first official post-quantum cryptography standards. Algorithms with names like Crystals Kyber and Crystals Dilithium, now officially known as MLChem and MLDSA, are being woven into the foundation of the next generation internet. And this is where Linux steps into the story in a huge, undeniable way. In 2024, the Linux Foundation launched what's called the Post-Quantum Cryptography Alliance, a coalition of industry leaders, researchers, and developers collaborating out in the open to build high-assurance versions of these new quantum-resistant algorithms. Not hidden behind a corporate wall, not buried in proprietary code only a handful of engineers can examine, built openly, reviewed by anyone with the know-how to check the math, constantly refined by a global community rather than one company's roadmap. One flagship project born from this effort is called Open Quantum Safe, or OQS. At its heart sits a library called Libox, an open-source C library loaded with quantum-resistant cryptographic algorithms. This library has become a genuine testing ground for integrating and evaluating post-quantum algorithms across operating systems, including Linux, Mac OS, and yes, even Windows. But notice something crucial here. The backbone of this movement, the actual engine room where this technology is being developed and stress tested, lives first in the open source Linux ecosystem. This isn't just theory sitting in some research lab, it's already running in real products people use every day. Red Hat Enterprise Linux 10 now supports post-quantum key exchange through the MLKEM algorithm, securing TLS connections established via OpenSSL, GNU TLS, and NSS, along with SSH connections through OpenSSH. That means secure web browsing and secure remote server access on Red Hat systems are already being fortified against a quantum future, today, not eventually. Rocky Linux, built by CIQ, has been moving down a similar road, weaving post-quantum algorithms into its Network Security Services module and pushing toward formal cryptographic certification. OpenSSL itself, the library underpinning encryption for a massive chunk of the internet, added post-quantum cryptography support starting with version 3.5, and it doesn't stop at software running on general-purpose machines either. Researchers have already pushed post-quantum encryption down into tiny embedded devices. Open-source firmware projects have shown full post-quantum handshakes completing in mere milliseconds on small microcontroller chips, the kind that power smart sensors, IoT devices, and edge hardware. There's also a growing open silicon movement bringing academic institutions and industry players together to build quantum-resistant cryptography directly into physical chips, not just the software layered on top. Researchers working on this hardware-level integration have already shown dramatic performance boosts, processing certain post-quantum algorithms several times faster than earlier versions while shrinking the memory footprint needed to run them. This matters because software fixes alone won't cut it. If the underlying silicon can't efficiently handle these new algorithms, the whole system bogs down, and sluggish security tends to get quietly switched off by frustrated users and admins. Even ordinary web servers got the memo. Nginx rolled out post-quantum cryptography support to help secure the connection between your browser and millions of websites worldwide. Akamai enabled post-quantum cryptography at the edge of its network, protecting traffic before it even reaches its final stop. This isn't one company patching one product quietly. This is an entire ecosystem, largely rooted in open source and Linux infrastructure, moving in coordinated step toward a quantum-resistant future. Here's why this distinction actually matters to you, the everyday person sitting there right now. Closed proprietary systems move at whatever pace their parent company decides. If a corporation is slow, distracted by other priorities, or simply doesn't prioritize security overall, users are left waiting with zero visibility into what's really happening behind the scenes. Open source Linux-based projects don't hit that same wall. Anyone can inspect the code, anyone can contribute a fix, anyone can audit whether the encryption guarding their data is actually doing what it claims. That transparency isn't just a nice philosophical bonus. In a world where harvest now, decrypt later attacks are already underway, transparency and speed of adoption could be the difference between your data staying private for decades or turning into an open book the moment quantum machines catch up. Now let's tie these two threads together because this is really the heart of the whole story. On one side, you have Windows, a closed, proprietary system that quietly gathers diagnostic data by default, hands users only partial control over what leaves their machine, and moves at the pace of one company's internal priorities and regulatory pressure. On the other side, you have Linux, an open-source ecosystem where the code is public, telemetry is opt-in rather than baked in by default, and the response to arguably the biggest cryptographic threat in modern history is already running in production systems, built by a global community instead of a boardroom. This doesn't mean Windows is secretly sinister or that Microsoft is lying about telemetry. The evidence genuinely doesn't support that level of conspiracy thinking, and a decade of independent investigation backs that up. But it does mean something important. In a world rapidly heading toward quantum-capable computing, the systems offering visibility, choice, and community-driven speed are going to matter more than ever. Linux isn't winning this race because it's flashy or trendy. It's winning because openness, by its very nature, forces accountability. When the code is public, there's nowhere to hide a shortcut. There's nowhere to bury a weak implementation. Thousands of eyes are watching, testing, and improving it constantly, for free. Let's talk timelines for a moment, because context really matters here. Google has publicly stated its own internal goal for finishing its post-quantum cryptography migration is 2029. NIST's official standard, FIPS 203, mandates quantum-resistant security across sensitive systems by 2035. These aren't casual suggestions. They're formal, published deadlines from some of the most influential organizations in tech and government. If the biggest players in the industry are treating this like an urgent, decade-defining priority, that should tell you something about how seriously you ought to take it too, even as an everyday user who just wants their messages and files to stay private. And here's a practical point worth keeping in mind. You personally don't need to become a cryptography expert to benefit from any of this. You don't need to manually install quantum-resistant algorithms on your own machine tomorrow morning. What actually matters is which ecosystems, which companies, and which operating systems are moving fastest and most openly to bake this protection into the tools you already use every day, quietly in the background, the same way telemetry works today, just aimed in a very different direction. That's exactly why choosing between an open, auditable system and a closed, opaque one stops being some niche hobbyist debate and becomes a genuinely practical decision about your own long-term digital safety. So what does all this actually mean for you, sitting there right now on whatever device you're using? It means the privacy conversation needs to mature a bit. It's not just about whether Windows is quietly logging your crash reports. That's the small, visible skirmish. The real battle, the one most people haven't even noticed yet, is whether the encryption protecting your entire digital life will survive the next decade of computing power. And right now, the most serious, most transparent, most rapidly evolving answer to that question is coming from the open source Linux world, not from closed corporate ecosystems moving at their own pace behind closed doors. If this video opened your eyes to something you'd never considered before, that's exactly why channels like this one exist. Hit that like button right now. It genuinely helps this video reach more people who need to hear it. And if you want to stay ahead of the curve on privacy, security, and the technology shaping your digital future before it hits mainstream news, make sure to subscribe, because this quantum shift is only just getting started, and you don't want to be caught behind when it fully lands. The uncomfortable truth is this: big tech companies aren't necessarily your enemy, but they're not your guardian angel either. They're optimizing for their own priorities, their own legal exposure, their own product roadmaps. Meanwhile, a quiet revolution is unfolding in open source communities worldwide, built by people who simply believe your data deserves to be protected by code you can actually inspect, not code you're forced to trust blindly. That revolution isn't waiting for permission. It isn't waiting for a corporate press release. It's already here, running on servers, powering secure connections, and quietly future-proofing the internet, one open source commit at a time. So the next time someone tells you Microsoft is watching everything, understand the nuance. Yes, telemetry exists. Yes, it gathers more than most users realize. But no, the evidence doesn't support the idea of secret spying on your personal files. The bigger story, the one that should actually keep you up at night, is the quantum threat quietly creeping up on every encrypted piece of data you've ever created. And the good news, if there is one, is that the open, transparent, community-driven world of Linux is already building the shield you're going to need. Like this video if it made you think differently about privacy and security. Subscribe if you want more breakdowns like this one, and I'll see you in the next video, where we go even deeper into the technology quietly rewriting the rules of the digital world.